Of all the stupid things governments like to waste our money on, the first thing that probably doesn't come to your mind is sci-fi weapons programs that look like they belong in a Hollywood movie. Considering what's happening these days, it probably does, but you get what I'm trying to say. So, what happens when the US government says to arms developers in the 1980s, "Hey guys, we want a new, more accurate rifle to replace the tried and tested M16A1, but we need it to improve hit probability and capabilities by 100%. Don't worry, you can get complete creative control to make whatever you want, and the US taxpayer will pick up the tab as long as it's more accurate than an M16. Well, you get a 4-year, $300 million horror show of cursed weapons that look like a war crime. This is the story of the Advanced Combat Rifle Program. It all started in the early 1980s when the US Committee on Armed Services asked the Joint Service Small Arms Program of the US Army to study the M16A1 and find out if it was still a competent rifle and the best choice for the military. They found that it was a good rifle, but could be improved. The technology base should be developed to support a significant improvement in capability, meaning the Army's new gun needed to move away from conventional ammunition and actions. They eventually began a long-term project to develop an advanced combat rifle that could use a new, radical ammo type. This project became the Caseless Ammunition Rifle System, or CARS, which transformed into the ACR Programme. The Advanced Combat Rifle Program began in January 1985 to foster the development and select a rifle that would give troops a distinct advantage on the battlefield. The project aimed to address the human shortcomings of the average soldier on the field. Combat stress, fear, and fatigue negatively impacted a rifleman's ability to hit a target once engaged in combat. The ACR program sought to compensate for this by maximizing hit probability when engaging fleeing targets in battlefield conditions. The program called for an enhancement in hit probability of at least 100% at combat ranges over the baseline performance of the M16A2 rifle at extended ranges. The improvement required will be greater than 100%. The weapon will be expected to enable the rifleman to detect targets at ranges greater than 400 meters in offensive action and at least 1,000 meters during the conduct of the defense. There was no pressure then, considering they were calling for a weapon with an optic and the ability to engage long-range targets wearing body armor and fleeing targets. It was asking a lot. However, the ACR program was far from the US military's first ambitious small arms project. The US government built the ACR program on the Special Purpose Individual Weapon SPIW program, established in the 1950s to produce the next generation of infantry weapons capable of firing bursts of flechettes at excessively high rates of fire to improve hit probability. This task proved technologically insurmountable during the 1950s and 60s. The SPIW program ended in the late 1960s, but was followed in the early 1970s by the Future Rifle Program, which was also a failure. Despite these failures, the programs helped to push small arms technological boundaries. The approaches used by the companies that entered the ACR competition varied greatly, ranging from rifles with complex buffer systems to weapons that fired duplex and flechette rounds. In September 1985, the US government made the first request for proposals, and 6 companies successfully submitted proposals. The government developed the ACR program in 3 phases. The first sent 6 contracts to AAI, Heckler & Koch, ARES, Colt, Steyr-Mannlicher, and McDonnell Douglas. The US contracted AAI and Heckler & Koch to explore salvo and caseless ammo types. Phase 1 concluded with a test fire of the rifles that eliminated ARES and McDonnell Douglas. In 1987, following Phase 1 of the program, ARES and MDHS were dropped due to hardware immaturity as the concepts were underdeveloped. Both companies appealed and were allowed to enter designs for Phase 2, but they were not good enough to compete in the later trials and testing. Phase 2 consisted of a basic testing of the rifles and their ammo types to ensure they were safe to enter a field testing phase. Phase 2 was a planning phase. However, the Navy and Marine Corps withdrew support from the program. Phase 3 occurred in 1989, and the military took the 4 rifles to Fort Benning, now Fort Moore. The US government instructed Army and Air Force personnel to use ACR rifles, and the M16A2 was a control group. The M16A2 had been the standard service rifle since 1982 up until that point. The Army put the contesting rifles through a grueling schedule of field testing that simulated combat conditions and exposed them to various environmental factors. It also scored on the evaluation of dispersion of fire, hit performance, ease of use, reliability, and safety. The 2 branches even ensured both men and women were involved in testing to see if gender discrepancies existed in how the weapons performed. Each company approached the program's aims differently. 2 utilized flechette technology, which the US had developed during the SPIW program, with the AAI using a brass-cased round, while the Steyr ACR used a polymer case. Colt's entry used a duplex round with 2 projectiles stacked in the cartridge case. The Heckler & Koch G11 used a complex buffer system to reduce felt recoil after firing a hyperburst of 3 rounds at 2,000 rounds per minute. Anyway, enough exposition. Let's begin with Steyr and AAI. They were both similar in their design. AAI Corporation had long been involved in advanced firearms design, partaking in the US military's previous programs. The AAI ACR was an evolution of the earlier SFR XM19 rifle. They also based it on an earlier design developed for the SPIW program. AAI's ACR was gas-operated, feeding from a 30-round box magazine, and fired a brass-cased flechette round in either a single shot or a high cyclic rate 3-round burst. The rifle used an ACOG 4x optic with a 21.3-inch smoothbore barrel. The gun fired long saboted flechettes from 5.56 casings and could not fire 5.56mm rounds. The flechettes were 1.6mm wide and 41.27mm long. They were swift and produced minimal recoil. The AAI ACR featured an integrated sound flash suppressor, without which it was deafening and would create a bright muzzle flash. It fired from a closed bolt, and the AAI had a muzzle device to reduce muzzle climb during burst fire. AAI developed a polymer saboted steel 10.2 GR flechette in a standard M855 brass case. As a result, the rifle used a proprietary magazine to avoid the accidental chambering of conventional 5.56 x 45mm rounds. These rounds had a muzzle velocity of 4,600 feet per second. The gun was designed to mount a quick detachable 4x optic and had a white highlighted shotgun-style rib sight along the barrel to aid in snap shooting. The rifle was one of the most extended entries, with an overall length of 40 inches or 101.6 centimeters. According to the ACR Programme summary, the AAI entry was a mature design which performed reliably during the field trials. Steyr Mannlicher's bullpup entry used a gas piston-driven rising chamber mechanism which rose and fell to chamber rounds as the action cycled. Like AAI's entry, the Steyr ACR fired flechettes, but Steyr housed their ammunition inside a cylindrical polymer case. The bullpup Steyr was the second shortest at 30 inches, 76 centimeters, and the lightest of the rifles submitted, weighing 8.5 pounds, 3.86 kilograms. The Steyr ACR borrowed its ergonomics from its conventional forebear, the AUG, with a molded green plastic stock and a similar pistol grip, trigger and safety layout. Unlike the AUG, however, the ACR used an AR-15 style charging handle at the rear of the sight mounting block. A variable 1 to 3.5 times optic could be attached to the rifle. The Steyr ACR had a 21-inch barrel, but was only 30.7 inches long. The gun did not use a conventional bolt. Instead, it had a rising chamber when fired from an open bolt. When a soldier pulled the trigger, a live round entered the chamber, thus reducing the potential for cook-offs. When a rifleman fired the gun, spent polymer cases were pushed out of the chamber and ejected from an opening just in front of the magazine well feeding from a 24-round box magazine made from the same translucent material used in conventional AUG magazines. The magazine went from double stack to single stack to allow it to feed reliably. As a result, they had to shorten the capacity. Steyr planned a high-capacity drum magazine but did not provide for the trials. The rifle fired incredibly fast 1.6-inch long flechettes, which moved at nearly 5,000 feet per second. By comparison, a 5.56mm round from an M16 moves at about 3,000 feet per second. The rifle had very low recoil and was the cheapest of the 4 finalists to produce. The polymer case held a fin-stabilized 9.85 GR flechette with a molded 4-piece sabot, which broke up soon after exiting the muzzle, which was identified as a shortcoming as it risked hitting nearby troops. For some reason, they decided in their infinite wisdom that they weren't going to shoot bullets but flechettes, which, if you didn't know, are large metal darts, and their logic behind doing this was that it would be more accurate. To put this into perspective, the muzzle velocity of a 556 round is approximately 3,000 feet per second, while an AK-47 7.62 x 39mm round travels roughly 2,200 feet per second. The flechettes, however, were leaving the barrel at 409,000 feet per second. Theoretically, this meant that the shooter didn't need to compensate for bullet drop, increasing accuracy. That's the general concept of what both companies built their rifle around, and that's where the similarities end, as Steyr decided they would place their flechette inside of a polymer-cased ammunition. The polymer case rounds weighed half as much as a brass case round, which sounds great because that meant you could carry more ammunition, which meant more accuracy by volume, and in the US Army, more is better. That's great in theory. The issue they ran into was when they fired a bullet. It's a small, controlled explosion, and when that happens inside a piece of brass, the brass absorbs much of the heat. Therefore, much of the heat was ejected from the weapon when the soldier fired the gun. Still, when you apply that to a polymer casing, the polymer doesn't absorb nearly as much heat before its ejection, meaning that all that heat goes back into the barrel. Therefore, the barrels wore out more quickly, and if you fired too much, the barrel got too hot. Then, if you put the polymer case ammunition into the chamber, it would cook off. The rounds would explode, and you would need to book an appointment with a reconstructive plastic surgeon. So the Steyr was out. AAI decided they were going to place their flechette inside of a 556 brass casing, and it was more effective. The barrels lasted longer, the rounds didn't cook off, and it seemingly fixed the issue that Steyr had. But the problem is, they put a flechette inside of a 556 round, which if you're not aware, is the same size as the M16 round, meaning that, in theory, you could stick these inside of an M16. You could stick a regular 556 ammo inside the AAI rifle, but as soon as you tried to fire a regular 556 round, it would probably book you a second appointment with that plastic surgeon. So that was the end of the AAI. Now it's time for the gun you've all been waiting for. It's the magnetic accelerator gun from 1993's Demolition Man, a documentary I like to call Life Simulator 2020's edition. The Heckler & Koch G11 rifle was the most radical of the 4 gun designs. It featured a bullpup layout and used an incredibly complicated internal mechanism. Heckler & Koch created a next-generation infantry weapon alongside the West German Bundeswehr. The result was the G11. The G11 had been in development since the late 1960s, and by the time H&K entered it into the ACR program, it had evolved into a complex weapon unlike any other. Utilizing a gas-operated rotary breech to fire self-contained caseless 4.73 x 33mm projectiles, H&K introduced a rotary breech chamber to clear misfired, broken, or defective cartridges from the enclosed system. The caseless design proved a lighter and smaller option for a 45 to 50 round box magazine. Multiple magazines could even be mounted to the gun for quick reloads. H&K sacrificed simplicity to achieve reliability. The US had awarded H&K a contract to develop caseless ammunition, optics, and the salvo concept in 1982. With the G11 in development, they then entered the ACR program. The bullpup H&K was the shortest of the weapons entered into the trial at 29.5 inches / 74.9 centimeters. The rifle had a variable 1 to 3.5 times optic designed by Swarovski. Dynamit Nobel AG developed the revolutionary ammunition. The finalized 4.73 x 33mm 51GR round comprised a solid propellant material body that encased a primer, booster, projectile, and a plastic nose cap. Dynamit Nobel developed the high ignition temperature propellant HITP to prevent accidental ignition cook-off of the ammunition's outer propellant body. The ACR program summary notes that most of the malfunctions/stoppages experienced in the field experiment were ammunition-related. H&K fed the ACR ammunition from a single stack, a horizontally oriented 45-round magazine that sat above the barrel. The G11 used a counter-recoil buffer mechanism to allow high rates of burst fire, hyperburst. When firing 3-round bursts, the weapon could send the rounds downrange at a rate of 2,100 rounds per minute. Only when the last round had left the barrel did the barrel and action begin to recoil inside the stock along a central guide. The recoil impulse was then quite strong. When in sustained fire, the rate of fire was closer to 460 per minute. The G11 fired caseless ammunition, and the red block was the propellant, or the black powder itself, which got burned up, and nothing ejected out of the gun. The Germans figured out how to solve the polymer case ammunition's heating issue by not having a casing, because, of course, they did. The internet has named this rifle Kraut Space Magic for a reason. While caseless ammunition is a cool idea, it won't make it more accurate. So their strategy was to make this gun shoot the aforementioned 2,100 rounds per minute in a 3-round burst. That meant that the rifle was so fast in 3-round burst mode that when you pulled the trigger, it would fire all 3 rounds before the person shooting the gun felt the recoil from the first bullet. And that worked out great, but after the 3rd round left the barrel, it kicked you like a horse. That's an interesting concept, and it did appear to work. So why didn't the US pick up the G11? The caseless ammunition was going to be extremely expensive. Germans designed this rifle, but they were left unsupervised and given zero budget, so naturally it was over-engineered. The gun was reliable, according to the testing. Still, it was so complicated that when it needed repairs, it had to be taken to Leonardo da Vinci just to get fixed, because the inside looked like a clock. So that was the end of the G11. It did get a cameo in a cult movie, which is more than can be said for the others. The final entry has to be respected, just for the bag between the legs of Colt it would have taken to pull this off, which is astronomical. Their entry was the most conventional of the designs submitted. Based on the rifle the program sought to replace, Colt's ACR was an improved M16, which fired conventional 5.56 x 45mm ammunition and a new 5.56mm duplex round. The 5.56 duplex load fired 1 cartridge with 2 projectiles to provide a soldier extra hit potential with every round fired. However, duplex rounds had significantly less accuracy at ranges beyond 300 meters than the standard M16A2. Anyone who'd ever fired an M16 could easily handle the Colt ACR. It's still a direct impingement rifle that fed from box magazines. While the duplex round increased hit probability at shorter ranges, it impacted long-range accuracy, requiring the additional use of conventional M855 rounds. It incorporated a variety of improvements, including a new oil spring hydraulic buffer to mitigate recoil, a reshaped pistol grip, and a handguard that mounted a sighting rib for snap shooting and multi-position stock. The weapon had a flat-top, upper-railed receiver, so a soldier could fit a 3.5x optic, an early ECLAN, or a more conventional sight/carrying handle. The rifle's collapsible, 6-position telescopic buttstock was an improved version of that offered with Colt's carbines. The Colt ACR was the most extended rifle tested at full extension, 40.6 inches or 103 centimeters long. Knight's Armament designed and added a distinctive proprietary muzzle brake compensator. During testing, one of the duplex rounds was not properly seated inside the cartridge case and, when fired, became lodged in the barrel. The weapon's barrel blew when a soldier fired another round during a firefight. A slightly larger propellant charge addressed this. The government employed features developed for the ACR entry in the M16A3 and A4. This rifle is a straight-up M16. There is nothing special about it whatsoever. Colt had been selling weapons to the US military for years. Between the M16 and 1911, they knew their audience and how to sell to Uncle Sam. Their design proposition when they walked into the lab must have been, listen guys, so while everyone else is making alien space technology, we're going to take an M16, slap a massive foregrip on it, and say that it helps with target acquisition, then stick a scope on top of that bad boy that makes it more accurate. We're going to design a new type of bullet, where 2 bullets go in one casing, and call it a duplex round. Their pitch was to sell the US government the same rifle, but every magazine now had 60 bullets, not 30, so it was double the fun. Or you could fire on semi-automatic. Anyway, the 3-round burst just became a 6-round burst. It's still full auto, but it's at 2 times speed. So it looked as if Colt was going to win the bid. However, someone realized the obvious and pointed out that the only thing making the gun more accurate was a scope. And all these other rifles have scopes. Why don't we try putting one of those scopes on a regular M16 and see what happens? Soldiers couldn't remove the scope on the G11 and the Steyr because they were European and too fancy and clever. But shooters could pop off the scopes on the Colt and the AAI, and when that happened, would you look at that? The M16 was more accurate than all the other rifles. So that is what the US military went with. The scope became the N134 that snaps on every 240, and to this day, the scope on the AAI is the ACOG. Now, all they had to do was buy a bunch of new scopes instead of new rifles. It's okay though. They were only in the red on the money it cost for all the research and development of 4 new guns from the ground up, which only cost the taxpayer $300 million to work out that putting a scope on a rifle does indeed make it more accurate. After several years of development, while the Army organized testing, the 4 firms delivered their prototypes in 1990. During Phase 3, they tested the rifles on the specially built Buckner range, designed to recreate field conditions and create fleeing targets at various ranges. The M16A2 was a baseline weapon throughout all the tests, including safety and engineering testing, lethality tests, and testing in field conditions. Initially planned as an all-services test, the US Navy and Marine Corps left the ACR program in 1987, leaving the Army and the Air Force. With the testing complete, none of the rifles proved significantly more lethal or effective than the M16A2. The program summary put a somewhat positive spin on the program's failings, concluding that the ACR program was a success despite the increased hit probabilities not being attained as a technology-based program. The soldiers taking part in the field tests performed better than expected, and the baseline performance of the M16A2 rifle was better than anticipated in terms of hit probability. The report concluded that the program had helped push small arms technology forward, noting that while flechettes proved too inaccurate for an individual weapon, the feasibility of caseless and lightweight plastic-cased ammunition has more than been demonstrated in this program. Few problems were experienced with the H&K caseless rifles in the test. The past technical barriers of cook-off and vulnerability have now been overcome. Plastic cases cannot be used in conventional weapons like the M16A2, but complete plastic cases are feasible with designed weapons. With the end of the ACR program, the school of thought moved towards high explosive and airburst munitions by individual soldiers. The Objective Individual Combat Weapon program ran throughout the early 1990s and led to the adoption of new weapons, such as the M320 grenade launcher. It also failed in its goal to create an integrated individual weapon system. In summary, governments are utterly useless at everything, and this proves it. This video is a tale of how America got ACOG scopes and M134 machine gun optics, and a cameo of a wholly impractical, space-age German laser rifle in a cool movie because they decided that it would be a brilliant idea to spend $300 million to replace a gun that didn't need replacing, and realizing that slapping a scope on top of the rifle does make it a more accurate weapon. After 4 years, numerous testing, and ungodly amounts of cash, the program was ultimately dissolved in 1990, failing to achieve its goals. They weren't paying for any of it, so I guess it was high fives. Hey guys, guess what? Here's more weird, futuristic, sci-fi alien technology the government wasted everyone's money on. Governments have a history of spending money on wholly unrealistic weapon systems that look like car doors and guitar cases. Who would have thought? We are going to discuss the OICW, or Objective Individual Combat Weapon Programme. Although this was an American program, they were not the first. Some previous iterations include Italy's Carcano Breda con Tromboncino M1927/M1928, the Swedish Carl Gustav NIVA XM1970, the Soviet AT.002 OICW, the French PAPOP project Polyarmy Polyprojectiles, the Australian DSTO AICW, the Chinese ZH-05, and the South Korean S&T Daewoo K11 DAW. What these guns have in common is they all look like pieces of luggage. This time, the US government decided to replace the M16 with a grenade launcher. Yes, you heard that right. The primary weapon in this horrific lineup was the XM29, which was a 20mm grenade launcher that fired programmable smart grenades on top and a G36 rifle on the bottom. It all began after the government came out to Vietnam and created the Advanced Combat Rifle Program, which created Starship Troopers weapons to replace the M16. After spending $300 million, they concluded that placing a scope on top of the existing M16 instead of building a new rifle would make it more accurate. So the government launched an internal investigation against itself, which always works out great, and you'll never believe what happened. The government determined that they did nothing wrong. The program didn't fail because of corruption or government ineptitude. It failed because the US government was such an innovator. The M16A2 was just too good a rifle. The government report recommended that if they wanted to maximize lethality, the only option to pursue was an explosive one. In other words, the US Army were all getting grenade launchers. Now it was government contract time. Unlike the ACR program, they had a declared winner for the bid, Heckler & Koch, with their submission, the XM29. Technologically speaking, this cursed weapon is impressive. H&K built the 20mm launcher in various configurations, including a 5.56mm solo launcher and the MP7 PDW. H&K based the design of the XM29 on the H&K CAWS, Close Assault Weapon System, which was a caliber 18.5x76mm or 12-gauge non-conventional experimental shotgun developed by H&K. The term SABR, Selectable Assault Battle Rifle, was also used at specific points, but is less common. Developed by Alliant Tech Systems, with Heckler & Koch as a major subcontractor, the most commonly seen version of the XM29 consisted of a semi-automatic 20x28mm smart grenade launcher, an underslung KE assault carbine derived from the HK-G36, then in its late developmental stage, firing a standard 5.56x45mm NATO round, and a top-mounted computer-assisted sighting system with integrated laser rangefinder, thermal vision, night vision capabilities, and up to 6x optical telescopic sight. The scope wasn't just a scope, it was a normal scope, a night vision scope, a thermal scope, a rangefinder, and a ballistic calculator all in one. With this setup, they pre-programmed the grenades before firing to airburst mode, so they blew up at a certain distance away from the gun, not necessarily before the grenade hit something. The launcher was a light, semi-automatic 20mm cannon, a grenade launcher, or an airburst weapon. It posed a classification problem. It did not fit neatly into any category. On one hand, it used much smaller shells and had a much flatter trajectory than grenade launchers. On the other hand, its caliber and velocity were more similar to that of a light cannon, and it shared traits with other infantry grenade launchers. So how did it work in practice? If an enemy combatant hid behind a concrete wall, the soldier would point the gun at the concrete wall, and then they would click a button near the trigger that told the laser rangefinder how far away the wall was. If the soldier wanted it to explode a bit past the wall, they hit the plus button. Then the grenade would be programmed to explode slightly past the distance of the location of the wall, so then they would fire the grenade right over the top of the wall, and it would explode as soon as it passed the wall, right on top of the enemy's head. If grenades were deemed too excessive for the situation, an underslung 5.56 rifle, a G36 with a bayonet lug, could be used. This weapon sounds pretty cool, so why didn't the USA adopt this weapon? In theory, it sounded cool. In practice, not so much. Without ammunition, this rifle weighed 18 pounds, which is extremely heavy for a firearm. To put that into perspective, an M16 with full attachments weighs about 12 pounds. This rifle was 50 pounds heavier. The XM29 had some awful design concepts. If you take an M16, the M203 grenade launcher had a separate trigger that allowed it to shoot grenades. The problem with the XM29 was that it had one trigger that shot both. The only differentiator between the two was the selector switch, called a KE, which stood for kinetic energy or bullets, and HE, which stood for high explosive. You could see why this would be a problem. One minute, you're trying to fire a warning shot. The next minute, you're vaporizing someone. The rifle was going to be a logistical nightmare. That enormous scope required batteries, and if you couldn't get any batteries, that meant the scope and the rangefinder wouldn't work, which meant you couldn't program the smart grenades. Now all you had was an 18-pound gun that was ultimately a 5.56 rifle with a 9-inch barrel at 5.56, which gave a range of 200 yards. The other problem was the grenades were not just grenades, but smart grenades, which meant that they had microchips placed in them. The issue with this is America isn't famous for making microchips. The places that they get their microchips from are countries that the US would go to war with, or countries bordering states. that they would go to war with, which would create a massive issue for ammo procurement. For these reasons, in 2004, the Chief of the Infantry stepped in and nuked the program. The problem was that the government brass and the weapons manufacturers didn't like this, because they were banking on this program being the justification for why they wasted $300 million on a failed rifle program. Now, they had already spent money on this program. How much? It was enough that they didn't want to tell the public how much money they spent. So they needed this program to work. So in their infinite wisdom, they split the gun into two pieces: the rifle to replace the M16 and a grenade launcher. The Pentagon thought this was a terrific idea. Supposedly, the only feedback they gave the project regarding the rifle was to make it more Starship Troopers-like. I'm not joking. They said this. The XM8 derives from this concept. Heckler & Koch delivered the first 30 XM8 prototypes by November 2003 for preliminary testing. Ultimately, this gun was a G36 encased in a plastic body kit to make it look more futuristic to sell to the US government. It could switch to being a bipod support weapon fired from a 100-round drum magazine. The main issue with this was drums have had a history ever since the Thompson machine gun of being unreliable, weighty, and awkward to transport. The XM8 had incredibly low stoppage rates, and the rifle was repeatedly tested as #1 in a dust test compared to the FNSCAR and the HK416. The XM8 only had 127 stoppages in 60,000 total rounds fired. For comparison, the M4 had 882 stoppages. If you loved the Picatinny rail system, that was unfortunate. H&K replaced the rail with a Picatinny combat attachment point. Instead, it functioned on small holes on the forward grip where you could attach accessories. It proposed they could even add a round counter. They wanted to track the number of rounds from each weapon fired from a specific date and time for each time an infantryman pulled the trigger. Perhaps they wanted to get better research on the results and performance of a weapon, or if a soldier got separated from their squad, their commanders wanted to know exactly where they were and what kind of engagement they were in so they could respond correctly. Their big selling point was that the XM8 was modular, which meant you could attach different barrel lengths to the gun, which made it more versatile in various types of combat. There was a short barrel for close quarters. For long-range combat, you could attach a longer barrel for improved accuracy. What a fantastic idea. The only issue is the M16 and M4 could already do those things, so it didn't offer anything new that those rifles already provided. So there was no reason to waste money in switching rifles. But this is the government we are talking about, so of course they were going to keep trying. They ordered at least 200 developmental prototypes. Among the complaints during testing is that the battery life was too low for the weapons-powered sight system and some ergonomic issues. Two other key issues were reducing the weapon's weight and increasing the resistance of the handguard, which would start to melt after firing too many rounds. Who would have thought it gets extremely hot and melts when you shoot bullets through a plastic gun? So the XM8 got binned in 2007. However, the Malaysian PASKAL unit of their armed forces adopted the XM8. Fear not, for they still had their trusty XM25 smart grenade launcher, and this piece of kit was utterly ludicrous. It's the same launcher as the one on the XM29, but they amped it up from a 20mm to a 25mm grenade to make it slightly more lethal. They switched the plan from equipping every soldier with a grenade launcher to equipping one soldier with a launcher that could fire off grenades at 700 yards. When Uncle Sam deployed the Grunts, Rangers and 101st Airborne, everyone loved it so much that they nicknamed it the Punisher. Various infantry leaders said it'll turn a 30-minute gunfight into a 3-minute one. The soldier could manually adjust how far the round detonated so they could hit enemies hiding behind cover. It possessed a maximum effective range of 600 meters. The launcher could fire 450 meters further than the M203 grenade launcher. That sounds cool, and it had a sick nickname, but that's where it ended. It was a huge tactical advantage in theory, so why, after years, did the government decide to get rid of it in 2016? People started a witch hunt, looking for anything the government could use against it in the history of the XM25. In 2012, a Ranger unit decided they would rather have a rifleman than this grenade launcher during a mission, so they presumed the weapon wasn't reliable. Perhaps it didn't occur to anyone that the Rangers were a special operations unit and they didn't require a grenade launcher for that particular mission. In 2013, there was an instance where the weapon malfunctioned one time, and all the safety features worked precisely how they were supposed to. However, the operator of the gun sustained a minor injury, so they used that as an excuse to trash the entire program, as the government had plausible deniability if they were doing it out of goodwill to protect the troops. Of course, it wasn't to protect their bottom line. The other minor problem that ended the entire program was the exploding bullets. Naturally, the last thing they were going to do was tell the public that exploding bullets has been technically a war crime since the 1800s. Since 1868, the Geneva Convention defined that if it's 400 grams or less, it is considered an exploding bullet. If it's more than that, it's a piece of ordnance. A 25mm grenade is less than 400 grams, so it essentially meant the entire project was technically a war crime and funded by hundreds of millions of dollars of taxpayers' money. Technically, it's only a war crime if the bullet explodes inside the enemy, and H&K meant for this round to explode over the enemy, so it shouldn't have been illegal. Here's the thing. If you could point a laser at the wall while someone was hiding behind it, then make the grenade explode a couple of inches past that wall, what was stopping you from aiming the laser straight at the enemy and making that grenade explode straight into them? So yeah, this is the story about the time that the US government decided they would spend 30 years, hundreds of millions to billions of dollars, thanks to inflation, to develop a grenade launcher that you could hunt aliens with whilst breaking every law in the Geneva Convention. Hey guys, what's up? Remember when I told you governments like to waste money on failed weapons projects? Here's another one courtesy of Uncle Sam. Today we will discuss the LSAT project. The LSAT light machine gun was part of the Lightweight Small Arms Technologies Programme, which aimed to develop a lighter yet highly reliable light machine gun, LMG, to enhance the mobility and firepower of infantry units. The journey began in 2004 when the Joint Service Small Arms Programme issued a significant challenge to the American defense industry to create lighter small arms and, crucially, lighter ammunition. The result of this initiative was the Lightweight Small Arms Technologies Programme. This weapon marked a considerable reduction in weight compared to legacy systems of that era, surpassing them in controllability and reliability. By 2008, the LSAT was available in two configurations, one that utilized case-telescoped ammunition and another that employed caseless ammunition. After extensive research and development into these technologies and their respective firearms, the government selected one variant for mass production. In May 2015, the military conducted tests by firing 85,000 case-telescoped rounds through 10 test weapons. Testers reported that the LSAT had established a new benchmark in weapon technology, providing reassurance about the project's advancement. Development began with creating two types of weight-reducing ammunition to produce a light machine gun intended as a test bed and technology demonstrator. Testers chose an LMG because it is significantly more complex. than infantry rifles. However, advanced computer simulations helped mitigate this complexity. Extensive computer simulations and modeling were employed to streamline the development process and reduce the time and costs associated with prototyping and testing. The program utilized a spiral development approach, releasing the weapon and ammunition in stages or spirals. Each stage produced a new version that improved upon its predecessors, allowing for continuous enhancement and refinement of the weapon system. The government held a competition to select design concepts from various companies, forming a team led by AAI Corporation to develop the weapon system. The US government supported defense companies to ensure the project's success. The parallel development of two types of ammunition allowed for flexibility. If the caseless ammunition efforts succeeded, the defense companies could continue developing the composite-cased weapon for production. Conversely, if the caseless ammunition project failed, the composite-cased version would likely continue to develop independently. The results were encouraging. Lightweight machine guns had reduced weight by 44% for cased telescoped ammunition and 43% for caseless weapons. Defense companies successfully met the secondary objectives. The LMG had the potential to significantly enhance battlefield effectiveness due to its simplified and consistent operation, lightweight design, low recoil, and stiffer barrel. This promise of improved effectiveness made the government hopeful about the LSAT's potential impact. Recoil compensation, which featured a long-stroke gas system, received positive feedback for its controllability. The LMG's simplified mechanism was also more reliable and easier to maintain. Developers included a round counter to enhance maintainability further, and the weapon could accommodate various electronic devices. Improvements in the materials used for the chamber and barrel reduced the gun's heat load, and importantly, the weapon's cost was comparable to existing models. For comparison, the standard LSAT machine gun weighs 9.4 pounds when empty, while a standard squad automatic weapon weighs 17.6 pounds. Additionally, cased telescoped ammunition is 40% lighter than traditional brass-cased ammo. Thus, a 100-round ammunition belt for the LSAT weighs about 2 pounds, while a brass-cased belt weighs approximately 3.3 pounds. The LSAT was designed as a traditional machine gun, incorporating several features that enhanced its functionality as a light machine gun. Key characteristics included a quick-change barrel, a vented handguard, a belt-feeding mechanism, and provisions for using an ammunition pouch. The firing rate is approximately 600 RPM. Additional features include a lightweight ammunition counter and a highly rigid, heat-resistant barrel achieved through fluting and specialized alloys. These design elements enhance the LSAT's capabilities and suitability for combat scenarios. When fired, the weapon's chamber pivots around a longitudinal axis, transitioning from a horizontal firing position to a vertically aligned feed position and then back again. A long-stroke gas piston facilitates this motion. A round is fed into the chamber at the feed position using a rammer, which also ejects any spent or dud rounds from the opposite side of the chamber. As the shooter fires, the rounds move forward parallel to the barrel and enter a separate mechanism that ejects them from one side of the gun. This design's advantages include its simplicity, the isolation of the chamber from barrel heat, and precise control over the movement of rounds during extraction and ejection. In the weapon's caseless firing version, developers introduced an additional mechanism to seal the chamber during firing, accounting for the caseless variant's slightly increased weight. In September 2011, the LSAT light machine gun underwent a 2-week assessment at Fort Benning, Georgia, where 19 soldiers evaluated its capabilities against the M249 SAW. The soldiers' rigorous testing and positive feedback confirmed the LSAT's effectiveness and underscored its potential to outperform existing machine guns, instilling a sense of excitement about its future use. Half of the soldiers in the assessment were armed with squad automatic weapons, while the other half used LSATs. They marched 6 miles in full combat gear and engaged targets to evaluate their stress levels and muscle fatigue. Another test involved the soldiers sprinting 200 yards while wearing body armor and carrying a basic ammunition load, followed by the rapid engagement of close-range targets. The third week featured soldiers from the 75th Ranger Regiment executing a live-fire squad maneuver in an urban environment. Feedback from the participants strongly favored the LSAT due to its lighter weight and reduced recoil. Many soldiers reported that the LSAT offered better accuracy compared to the SAW. The semi-automatic option also made it more suitable for room-clearing operations. One ranger even remarked that the LSAT performed better than the Mk-46 machine gun used by Special Operations Forces. Of the 19 soldiers who participated in the assessment, 15 preferred using the LSAT in combat over the SAW. The LSAT light machine gun is 41% lighter than the 20.5 pounds, 9.8 kilograms SAW and has 12% less ammunition volume. This allowed all soldiers maneuvering through the woodland obstacle course to complete it more quickly while carrying the LSAT. Participants also took less time to zero their machine guns with the LSAT. One soldier who struggled to zero the SAW accurately was able to zero the LSAT successfully on the first attempt. On average, LSAT users completed the obstacle course 1 minute and 11 seconds faster than SAW users. This advantage stemmed from increased mobility due to the LSAT's shorter length, adjustable stock, and lighter ammunition. Gunners experienced virtually no recoil when firing the LSAT light machine gun. The 8 prototype weapons fired 25,000 rounds, advancing their case telescoped ammunition to technology readiness level 7. The Army's dismounted non-networked experiment evaluated the LSAT light machine gun in August 2013 at Fort Benning. This evaluation was part of an event from August 24th to September 24th, 2013, which showcased the Army's latest developments in individual and squad equipment. During this event, testers provided 7 LSAT light machine guns and 9,700 rounds of ammunition to 3 rifle squads and 1 weapon squad for range testing. The evaluation highlighted several advantages, including increased lethality across all ranges due to faster engagement speeds and improved shot placement. Additionally, the lighter size and weight of the gun enhanced the mobility of the gunner, allowing for more precise firing in standing and kneeling positions. The designers of the LSAT project anticipated further improvements, which included advancements in projectile technology, such as environmentally friendly bullets, adjustments in bullet size to enhance combat effectiveness, and the integration of electronic features like ammunition count readouts, lasers, optical sights, rangefinders, and bullet drop compensation. The Army was actively pursuing the development of telescoped ammunition, with significant progress already made by that time. With strong support, they planned to field a new light machine gun in 2022. Meanwhile, the Marine Corps began exploring caseless ammunition, which is less developed and will require additional years for refinement. A compact version of the LMG is currently under development, featuring a 4-inch shorter barrel and a folding, telescoping buttstock. The 5.56mm LSAT machine gun has been renamed the Case Telescoped Light Machine Gun CT-LMG. On May 14, 2014, the government awarded Textron Systems a 2-year contract worth $5.7 million to develop 7.62 NATO Case telescoped ammunition and an operating mechanism for the LSAT machine gun. This resulted in a lightweight 7.62mm variant. At the 2015 Special Operations Forces Industry Conference, Weighing 14.5 pounds, 6.6 kilograms, it is nearly 8 pounds, 3.6 kilograms lighter than the 22 pounds, 10 kilogram version, and significantly lighter than the 27 pounds, 12 kilogram variant. Developers anticipated that a firing prototype would be ready by fall 2016. Throughout 2016, the LSAT Programme advanced the 7.62mm LMG to Technology Readiness Level 7 with extensive range testing. The program also completed the development of a 6.5mm variant of the 7.62mm CT cartridge, successfully testing that model. By the end of 2016, the program demonstrated target weight savings and advanced the development of more capable, longer-range 6.5mm ammunition. In July 2018, the US Army announced a new initiative to develop a replacement for the current light machine gun. 6 companies, including Textron, competed to create the next-generation squad weapon program, which aimed to replace the squad automatic weapon and develop at least 20% lighter ammunition. The NGSW program established specific physical requirements, targeting a weight of 12 pounds, 5.44 kilograms, and a length of 35 inches, 890 millimeters, while using a desired 6.8mm bullet. The government awarded contracts for the NGSW AR prototypes in July 2018, and contractors delivered prototypes and ammunition for Army evaluation by June 2019. Eventually, the Army tested prototypes for both the NGSW-R and NGSW-AR. The NGSW program effectively replaced the LSAT program. As of 2024, Textron has lost the NGSW contract, and the new model will replace the existing light machine gun. So, while not a complete failure, the government had a great project and ultimately decided not to pursue it in its original form for no apparent reason. This is a classic example of the brass not listening to their troops, which, of course, has never gone wrong. Hey guys, today we will discuss a failed weapons system that isn't from the US. It's from the land of Crocodile Dundee. Metalstorm Limited, based in Brisbane, Australia, was a pioneering research and development company known for its advanced electronically initiated superposed load weapons technology. J. Mike O'Dwyer founded the company and held proprietary rights to this revolutionary electronic ballistics technology, which inspired Metalstorm. The key innovation in Metalstorm's arsenal was superposed load technology. This technique involves stacking multiple projectiles nose to tail within a single gun barrel, with propellant placed between each projectile. This design is reminiscent of a Roman candle, a type of firework in which the propellant ignites the following charge as it burns down the barrel. This unique approach allows for the sequential discharge of projectiles from a single ignition, significantly enhancing firing capability. Metalstorm had explored various methods to ignite each propellant package, developing a shoot-on-demand feature. When applied to modern firearms, this feature enabled rapid and continuous firing, representing a significant advancement in weapon technology. The Italian inventor Giambattista della Porta introduced the concept of superposed loads in firearms in 1558. In the 1790s, gun designers created the experimental Chambers gun in Pennsylvania. This unique 7-barrel tripod-mounted volley gun operated similarly to the Metalstorm gun, utilizing superposed loads. However, due to their high cost and impracticality, neither superposed small arms nor mounted guns were adopted for military use. In the early 1990s, Mike O'Dwyer observed that existing methods were ineffective in addressing the issue of unintended propellant ignition. Highly pressurized hot gases could leak past remaining projectiles in the barrel, a phenomenon known as blow-by, which had the potential to ignite their charges. O'Dwyer's original Metalstorm patents provided a solution by arranging projectiles in a series along the length of the barrel. This design allowed combatants to fire projectiles sequentially and selectively, reducing the risks associated with unintended propellant ignition. In the original Metal Storm patents, an electronically fired primer ignited the propellant located just behind the projectile closest to the muzzle of the gun barrel. This ignition would set off the projectile and generate a reactive force that pushed the stacked projectiles backwards. Metal Storm designed the remaining projectiles to deform under the force to accommodate this, expanding radially against the walls of the gun barrel. This expansion created a seal known as obturation, which prevented the hot propellant gases, expanding behind the lead projectile, from leaking past and prematurely igniting the other propellant charges within the barrel. The design allowed for the ignition of each propellant charge selectively and electronically, unlocking the projectile in front and propelling it down the gun barrel, while reinforcing the radial expansion and seal between the remaining projectiles and the barrel wall. Subsequent designs removed the concept of a distorting shell sealing against the barrel. They adopted a new system incorporating the propellant within skirts that form the rear part of each projectile. These skirted projectiles differ from conventional shells and cartridges in that the skirts are an integral part of the projectile and are open-ended at the back. When a soldier fires a projectile, the nose of the projectile, following it in the barrel, creates a rearward seal for the skirt. This firing generates a backward impulse on the remaining projectiles stacked in the barrel. As a result, the skirts of these remaining projectiles compress against the heads of the following shells, effectively creating a seal that prevents the hot gases in the barrel from unintentionally igniting the propellant, thereby mitigating the risk of blow-by. Among the proposed and prototype weapons developed by Metal Storm was the impressive Bertha, a 36-barrel rig designed as a proof-of-concept demonstrator. This rig achieved an astonishing fire rate of 1 million rounds per minute. It fired 180 shots at approximately 27,777 rounds per minute from each barrel, lasting only 0.01 seconds. Making it the fastest firing gun ever. When firing at maximum capacity with 1,600 barrels, the weapon achieved a theoretical maximum rate of fire of 1.62 million rounds per minute, creating a dense wall of 24,000 projectiles with just 0.1 meters of spacing between follow-up shots. However, it was limited in practicality to pressure issues that arose when firing while the previous projectile was still in the barrel. Metal Storm unveiled a prototype of the 36-barrel system in June 1997. The Metal Storm VLE, also known as the O'Dwyer VLE pistol, was a proof-of-concept demonstrator highlighting the potential for miniaturizing advanced weapon technology. Metal Storm developed several variants featuring either rear-inserted barrels or break-open frames. The most common version showcased in the TV series Future Weapons was 4 barrels, with 2 9mm lethal barrels and 2 50mm less lethal barrels. This VLE pistol also offered insights into how the company could further miniaturize the technology. Interestingly, Metal Storm's innovations captured the attention of popular culture, making an appearance in the fictional world of CSI Miami. In Season 6, an exaggerated version of the Bertha rig, referred to as the DX4 vaporizer, was featured. With its 229 barrels, this fictional weapon is often mistakenly associated with the actual Metal Storm technology online, highlighting the ongoing intrigue surrounding this advanced weaponry and its ability to captivate audiences. The Redback was part of a series of 40mm implementations of Metal Storm technology used in grenade launchers and mortars, where the variability in per-shot accuracy is less concerning. The Redback system was a 4-barrel remote weapon station derived from the Metal Storm Area Denial Weapon System ADWS. While Metal Storm designed the ADWS as an area saturation weapon that could be concealed and triggered as an alternative to permanent minefields, Metal Storm created the Redback to replace the Mk19 grenade launcher on vehicles and drones. It served both as an offensive weapon system and a counter-RPG system. Metal Storm initially intended early variants of the Redback to use air-bursting grenade projectiles developed by ST Kinetics, with each barrel capable of holding 4 shots. However, the later Firestorm version does not reference this feature and appears to function solely as an offensive weapon system. A larger variant called Firestorm Fury was proposed to the US Marine Corps as part of the Marines Mission Payload Module Non-Lethal Weapon System NLWS program. This system could mount between 4 and 30 barrels containing 6 grenades in each barrel. The goal was to develop a crowd control launcher capable of firing CS gas, stun grenades, or a wall of flashbangs. A soldier could mount this launcher on various platforms, including the Marine Corps Transparent Armored Gun Shield MCT-AGS for the Humvee. However, the US government awarded the MPM NLWS contract to General Dynamics. Metal Storm introduced several innovative weapon systems, including an inductive electronic ignition system that ignites the propellant outside the barrel. They also developed a minigun featuring a belt of separate firing chambers. The MAUL multi-shot accessory underbarrel launcher was a semi-automatic, electronically fired 12-gauge shotgun based on Metal Storm technology. Metal Storm designed the MAUL to compete with pump or bolt action accessory shotguns like Knight's Armament Master Key and the M26 MASS. Soldiers could use the MAUL as an accessory weapon with various firearms like the M4 or M16 rifles. The MAUL featured a front-loading 5-shot preloaded barrel and could fire standard slugs, shot, or less lethal rounds. A combatant could only use one type of load at a time. It could fire a variety of munitions, including both lethal options such as buckshot and slugs, and non-lethal options including blunt impact, door breaching, and frangible rounds, all preloaded into 5-round stacked projectile tubes. Metal Storm reported the first shoulder firing of the MAUL during tests conducted on April 24, 2009 at their facilities in Chantilly, Virginia. The 3GL was a 3-shot semi-automatic grenade launcher developed as an offshoot of the Australian AICW Programme. This launcher could be mounted on various weapons using Rail Interface System RIS rails or utilised as a standalone unit with a folding stock. It featured a breech loading mechanism similar to a standard underbarrel grenade launcher UBGL. However, it employed proprietary grenade rounds designed so that the heads of the second and third loaded rounds fitted into the base of the round in front of them. This unique design allowed for stacked rounds without needing a preloaded barrel. The 3GL used a pseudo-caseless design system similar to VOG grenades, eliminating the necessity to eject spent casings. Instead of a direct electrical connection to ignite the propellants like other Metal Storm weapons, it utilized induction coils around the barrel for ignition. Unfortunately, this concept was unsuitable for carbines, as the bulky design would significantly unbalance any weapon more minor than a full-sized rifle when loaded. Despite its target weight of 5 pounds when loaded, it would still weigh 2/3 as much as a loaded M4 carbine. The main limitations of this technology relate to reloading and variable ballistics. Firstly, when a combatant emptied the barrel, all Metal Storm weapons, except for the 3GL model, once the shooter released the barrels, required the entire preloaded barrel or a barrel section to be replaced. Secondly, because Metal Storm designed the ammunition to be stacked in the barrel, each successive projectile traveled through a longer barrel, resulting in slight differences in ballistics, which significantly limited the practical applications of the technology to mortars and repeating area suppression grenade launchers, where varying accuracy is less of a concern. Additionally, the reliability and durability of the batteries and electronics pose challenges for Metal Storm devices. These systems are less dependable than mechanical firing pins, since they rely entirely on electrical ignition. Furthermore, because each shot required a longer barrel, Metal Storm weapons had a lower ammunition capacity than magazine or cylinder-fed guns of the same length. For instance, a Metal Storm version of a 5.56mm round, similar to the caseless round used in the Heckler & Koch G11, would require a barrel section measuring 39 inches in length to accommodate a 30-round STANAG magazine. In 2000, the Chinese government offered Metal Storm $100 million to further develop the technology in China. However, the company's founder, O'Dwyer, declined the offer and informed the Australian Department of Defence, which confirmed discussions but declined to comment on the details. Despite this, the concept behind the weapon system garnered interest in China, leading to research into its potential applications for naval vessels and armoured vehicles. This research even considered using the technology to intercept incoming anti-tank guided missiles. In June 2003, Metal Storm agreed to provide technology to Thunderstorm Firefighting Pty Ltd to develop a civilian application for its technology in bushfire fighting. On June 27, 2003, Metal Storm secured funding from the US military. In 2005, O'Dwyer left the company with a payout of $500,000, half of his stake valued at $43 million. He intended to sell it, but could not find a buyer for his shares. On November 19, 2007, the US Navy announced it would purchase grenade barrels from Metal Storm. In August 2010, Metal Storm signed a contract worth $3,365,000 with Papua New Guinea's Correctional Services Minister, Tony Amo, to supply 500 MAUL weapons and 10,000 less lethal barrels for use by correctional officers. However, it was unclear if any of these were delivered. Overall, the technology has not been particularly successful. However, Metal Storm produced a range of concepts and prototypes. In July 2012, the company suspended its shares and Metal Storm Ltd entered voluntary administration. Subsequently, their US-based subsidiary, Metal Storm Inc., filed for Chapter 7 bankruptcy in October 2014. In August 2015, Defentex, an Australia-based defence research and development company, acquired Metal Storm's intellectual property, trademarks, and other assets to continue developing and commercialising the technology. In July 2018, Defentex formed a joint partnership to provide weapons pods for the experimental Cerberus UAV. In August 2022, Defentex sold 300 D-40 kamikaze drones to the Australian government, subsequently donating them to the Ukrainian ground forces. While ambitious and innovative, the US regarded Metal Storm as an impractical application of military technology. However, the fact that China was willing to invest $100 million in Metal Storm technology suggests they recognized its potential and are developing their systems based on that design. Perhaps Metal Storm sparked a trend of experimental technologies pursued by Chinese and Russian militaries. Where we see shortcomings and high costs, they may see opportunities for innovation. Given the current state of Western military capabilities, we may have missed an opportunity by being closed-minded to new technologies to vaporize us all. We all have unusual ideas occasionally, but we rarely act on them. Those ideas often don't turn out as we hoped when we take action. However, some people turn their unconventional ideas into government contracts worth millions of dollars. Nowhere is this more ubiquitous than in weapons development and government contracting. Today, we will discuss the story of the XM8 rifle. The XM8 was a rifle produced by Heckler & Koch. It originated from the OICW Weapons Programme, which was sanctioned by the US government and funded with hundreds of millions of dollars. Although this program ultimately failed to deliver an effective weapon, it did lead to the development of the XM8. The XM8, a modified version of the G36 rifle, stands out with its unique features. It features a plastic body kit, a design choice intended to reduce weight. The project originated from the XM29 design by Alliant Tech Systems, which was not suitable for mass production. As a result, the Army split the components, leading to the creation of the XM25 grenade launcher and the XM8 rifle, each with its distinct features. The design of the XM8 was derived from a Pentagon directive to Heckler & Koch to create a weapon that resembled something from Starship Troopers. This directive embodied the US military's aspirations for futuristic weapons that could fit into a science fiction narrative. It began when Heckler & Koch delivered the first 30 XM8 prototypes for preliminary testing in November 2003. The XM8 could be used as a bipod support weapon, firing from a 100-round drum magazine. However, a significant issue with this design was that drum magazines have historically been unreliable, heavy, and cumbersome to transport, dating back to the Thompson machine gun. In autumn 2007, the military compared the XM8 to other firearms in a dust test. They based the competition on two previous tests conducted in the summers of 2006 and 2007, preceding the latest test in autumn 2007. In the summer 2007 test, M16 rifles and M4 carbines recorded a total of 307 stoppages. In the autumn 2007 test, the XM8 recorded only 127 stoppages in 60,000 total rounds, while the M4 carbine had 882. The FN SCAR had 226 stoppages, and the HK416 had 233. The difference between the XM8, HK416 and FN SCAR was not statistically significant when correcting for the less reliable Stanag magazine. However, the discrepancy of 575 stoppages between the summer and autumn 2007 tests of the M4 prompted officials to investigate possible causes for the change, including differences in officials, seasons, and an inadequate sample pool size. Nevertheless, they stated that the conditions of the test were ostensibly the same. If you were a fan of the Picatinny rail system, you might have been disappointed by its replacement in the XM8. H&K substituted the standard rail with a Picatinny combat attachment point. Instead of using the standard rail, the XM8 features small holes on the forward grip for attaching accessories. It also had an integrated optical sight and an infrared IR laser aiming module/illuminator. The design team proposed adding a round counter, allowing users to track the number of rounds fired from each weapon and record the specific date and time whenever a soldier pulled the trigger. This capability could provide valuable data for research on firearm performance and safety. Additionally, commanders would gain access to information about their location and the nature of their engagement if soldiers were to separate from their squad, thereby enhancing their ability to respond effectively. The XM8's primary selling point was its adaptability, thanks to its modular design. This design feature, not readily achievable with the M16 and M4 rifles, allowed users to attach different barrel lengths to the gun, thereby enhancing its combat versatility. For instance, a short barrel was available for close quarters engagements, while a more extended barrel could be attached for long-range combat, thereby improving accuracy. Despite concerns, the government was determined to ensure the success of the XM8 program, particularly since it had already faced one failed initiative. They needed to justify the hundreds of millions of dollars spent without achieving tangible results. As a result, the military ordered at least 200 developmental prototypes. During testing, several issues were identified, including complaints about the battery life of the weapon's sight system and ergonomic design flaws. Additionally, two main concerns emerged: the need to reduce the weapon's weight and improve the handguard's durability, which tended to melt after extensive firing due to its plastic construction. After completing the main testing of the XM8 rifle, the Army sought funding for an extensive field test. However, in 2004, Congress denied a request for $26 million to fund the procurement of 7,000 rifles for a wide-scale fielding test scheduled for 2005. At that time, the gun still had unmet developmental goals, particularly in terms of weight. At the same time, H&K improved the battery life and added a more heat-resistant plastic handguard. However, the weapon's overall weight remained a concern. The earliest product brochure listed the target weight for the carbine variant at 2.6 kilograms, 5.7 pounds. but the then current prototype weighed 2.8 kilograms, 6.2 pounds. By January 2005, according to a brochure released by H&K and General Dynamics, the weight of the carbine prototype had increased to 3.4 kilograms, 7.5 pounds. During the same period, the Army faced pressure from other arms manufacturers to open the XM8 to competition. The primary argument was that the adopted weapon significantly differed from the original system, for which ATK and H&K had won the contest. Additionally, there were concerns that the Army had a legal obligation to prioritize US-based manufacturers, and a previous agreement with Colt Defense required the Army to involve Colt in specific small arms programs. As a result, the XM8 program was on hold in 2004. The exact reasons for this decision are subject to debate, but it likely involved a combination of the technical issues mentioned, funding restrictions, and external pressures. In 2005, the Army issued a formal request for proposals for the Objective Individual Combat Weapon Increment 1 family of weapons. This RFP provided manufacturers with 6 months to develop and deliver prototype weapons that met requirements similar to those of the XM8, but with the addition of squad automatic weapon configuration. No XM8 prototypes have demonstrated the capabilities of the M249, such as fast barrel replacement, a high sustained rate of fire, and belt feed. The OICW Increment 1 requirement for the SAW included the need for fast barrel replacement and a high sustained rate of fire, while leaving the choice of ammunition feed to the manufacturer. The US government approved funding for the M320 grenade launcher, a single-shot underbarrel launcher similar to the M203, initially intended for the XM8 assault rifle. Although this launcher was heavier than the M203, it offered certain advantages, such as not requiring special mounting hardware and allowing loading from the side instead of the bottom. This design enabled the use of grenades that were longer than standard. The XM320 was created for use with the existing inventory of M16S and M4S, and was also compatible with the XM8. It could also function as a standalone weapon. As of July 19, 2005, the OICW Increment 1 RFP was placed on an 8-week hold, indicating that the US government was restructuring the program as a joint procurement initiative. On the 31st of October 2005, the US military cancelled the OICW Increment 1 RFP. An article published in Jane's Defense Weekly on April 26, 2006 states, "The US Army has again delayed the procurement of its future infantry weapons, this time for more than 5 years, and is working to field 2 interim guns in the meantime." General Dynamics was involved in the later stages of the project, and Heckler & Koch planned to produce the rifle at a facility in Georgia. Initially, H&K was British-owned, but a group of German investors eventually repurchased it. Developers conducted engineering work for the gun at United States and German facilities. The US military's XM8 program nearly faced cancellation in the autumn of 2005 after being suspended earlier that year. However, the Marines' use remained limited. If the government hadn't specifically designated the program for the Marines, the XM8 system might have encountered competition from other weapons, such as the FN SCAR, Bushmaster ACR, and HK416. The XM8 was later modified and submitted as a contender in the SCAR competition, but was unsuccessful. Ultimately, the US government cancelled the program. Although the XM8 performed reliably, it did not offer anything innovative, as it was modified from a rifle already in production. H&K discontinued the XM8 in 2007. However, despite its cancellation, the Malaysian Pascal Armed Forces unit of the Royal Malaysian Navy chose to adopt the XM8 in limited numbers, though it has not seen any combat use. Despite its limited real-life applications, the XM8 is well known primarily due to discussions on the internet and its depiction in films, although the latter is to a lesser extent. It has gained notoriety mainly through video games. The XM8's most notable film appearances was in XXX State of the Union, the sequel to the original XXX. Due to its unavailability, a modified G36 rifle mimics the XM8, which is ironic given its origins. In the opening scenes, ninja-clad super soldiers utilize the XM8 to attack an underground base, showcasing it as a futuristic weapon for a futuristic soldier. It also makes a less prominent appearance as a fake prop in the dystopian thriller Children of Men, where militarized police use it in a bleak, 1984-inspired Britain, most likely chosen for its futuristic look, perfect for a futuristic setting. In this world, the country functions as a surveilled authoritarian nightmare, while the rest of the world has already collapsed. This portrayal seems prophetic, particularly in light of the current direction the world is heading. After its cancellation, the XM8 reached a new level of popularity due to its futuristic design, making it an appealing choice for military-themed video games developed by various companies. Typically associated with highly classified special operations groups that require cutting-edge weaponry unavailable to the average soldier, the earliest variants of the XM8 appeared in multiple games of varying quality. These include titles such as Soldner Secret Wars, Conflict Global Terror, Splinter Cell Chaos Theory, Splinter Cell Double Agent, Ghost Recon Advanced Warfighter, Ghost Recon Advanced Warfighter 2, Battlefield Bad Company, Arma 2, Crisis, Black Site Area 51, Metal Gear Solid 4 Guns of the Patriots, Soldier of Fortune Payback, Rainbow Six Vegas, Rainbow Six Vegas 2, and Mercenaries 2 World in Flames. In the 2010s, the en vogue theme was games featuring futuristic military technology. As time passed, interest in sourcing obscure and experimental military weapons for licensing in video games became increasingly in demand, cementing their pop culture relevance. A slew of futuristic-themed military shooters featured the weapon in some form. Examples include Alpha Protocol, Battlefield Bad Company 2, Shadow Harvest Phantom Ops, Crisis 2, Call of Duty Black Ops 2, Warface, Sniper Ghost Warrior 2, and Battlefield 2042. The XM8 was an attempt by the West to develop a modern rifle that could meet the demands of contemporary warfare, rather than relying on traditional firearms that had proven effective in the past. Although it faced criticism for its limitations in military use, its popularity in video games suggests that our expectations of technological advancement may often be shaped more by fantasy than by reality. The US government envisioned the XM8 as a futuristic rifle designed for future conflicts, intended to be operated by what they referred to as future soldiers. However, it turned out to be a superficial prototype of an existing battle rifle, merely encased in plastic. It is noteworthy that its most prominent appearances were as a prop in the film Children of Men and as a mock-up of the G36 in XXX State of the Union, both of which highlight its derivative nature. In the dim light of a garage workshop, the whine of a metal file and the clatter of hardware echo an idea that would challenge the boundaries of law and society. What if anyone, anywhere, could build a working firearm with nothing but basic tools and a few supplies from the local store? This question was at the core of Philip Andrew Luty's life and legacy. Born in 1964, Luty was not just an activist. He was a provocateur whose homemade guns and widely circulated manuals sparked global controversy. His blueprints became more than schematics. They became symbols in the war of ideas, raising unsettling questions about the reach of legislation, the power of protest, and the unpredictable consequences of sharing knowledge in a connected world. The impact of these designs has echoed far beyond Luty's own workshop. Homemade firearms built from his instructions have turned up in criminal and terrorist investigations around the world, from the hands of gangs in Australia and Brazil to extremist plots in Indonesia and Myanmar. Perhaps most infamously, a Luty-inspired weapon was used, and repeatedly malfunctioned, during the live-streamed 2019 Halle synagogue attack in Germany, a chilling testament to both their accessibility and their limitations. For Luty, the act of building and sharing was a form of protest as much as engineering. He believed that by equipping ordinary people with the means to make fully automatic firearms, he was exposing what he saw as the futility and the danger of government overreach. Convicted in 1998, he served time in prison, his protests continuing even behind bars, where he fought the authorities on everything from his security classification to his right to grieve for his mother. His battles with the law did not end there. In 2009, anti-terrorist police raided his home, accusing him of creating records that could aid terrorists in possessing pipe components usable as firearms. Meanwhile, suspicions swirled around his involvement in a harassment campaign, though evidence proved elusive. When Luty succumbed to cancer in 2011, his passing closed the book on a series of legal struggles, but not on the debates he had sparked. At the heart of Luty's work were innovative and controversial designs. He produced several types of homemade guns, especially 4 distinct submachine gun models. His most famous blueprint, meticulously detailed in Expedient Homemade Firearms, outlines how to transform ordinary hardware store materials, such as sheet metal, bar stock, washers, and hex screws, into a functioning weapon. These are blowback-operated firearms that rely on the force of each shot to cycle the action, without the need for intricate locking systems. Even the magazine and pistol grip are crafted by hand, a testament to both the ingenuity and the accessibility of the method. Yet, for all their ingenuity, these weapons are defined as much by their flaws as by their function. With smooth-bore barrels that lack the rifling needed for true accuracy, the guns are crude and imprecise. Features such as shoulder stocks and sights are missing, making aiming difficult. Additionally, the absence of factory-level quality control means that performance is unpredictable. In the hands of different builders, the same blueprint can yield very different results, some dangerous, others barely operational. Despite these shortcomings, 2 original examples of the Luty SMG 9mm Parabellum have been placed in the British National Firearms Centre and are exhibited at the Royal Armouries Museum in Leeds. Their presence there stands as a testament to their dual legacy, technical curiosity, and a stubborn symbol of protest against gun control. Across continents, these blueprints have circulated. Firearms based on Luty's designs have appeared in South America, Europe, Southeast Asia, and the UK. While their presence in high-profile incidents has drawn international attention, repeated malfunctions and design limitations often reveal the gulf between theory and real-world lethality. The philosophy driving this movement was clear: to demonstrate that with sufficient resourcefulness, even the strictest laws could be circumvented. Luty's approach was a direct challenge to the very premise of state control, and it foreshadowed future projects such as Defense Distributed's 3D printed Liberator pistol. But where American innovators could operate within the law, Luty's campaign led him to a prison cell, his protests criminalized, his message undiminished. Today, the legacy of Luty's blueprints lingers, provoking debate and fueling reflection. When the knowledge to sidestep the law is only a click away, where do we draw the line between innovation and danger, protest and provocation? In the story of these homemade weapons, we find a cautionary tale that in the modern world, ideas can be just as volatile and as difficult to control as the weapons they inspire. Russia is renowned for the AK-47, but Soviet innovation extended well beyond it. In the 1970s, Tishnitokhmast engineers developed the experimental 80.002, a hybrid assault rifle and grenade launcher with dual side-by-side barrels, one firing 5.45 by 39mm rounds, the other launching a specialized 12.7mm grenade. The concept stemmed from Viktor Yakushchev's 1966 double-barreled AO-38 rifle, which laid the foundation for later advancements. Engineers V.S. Yakushchev, U.V. Minayev, V.I. Chelikin and G.A. Yanov developed the 80.002 prototype between 1975 and 1979 using the AK-74 as a base. Its thickened receiver housed a dual-piston bolt carrier with two independent barrels, 5.45mm right and 12.7mm left. Fed by separate 30 and 10 round magazines, the gas-operated system enabled single or automatic fire from the 5.45mm barrel and semi-automatic fire from the 12.7mm barrel. Early versions required caution to avoid firing both barrels simultaneously. The 12.7mm grenade system, though innovative, was less effective than standard 40mm grenades. Combined with the weapon's bulk and complexity, these shortcomings prevented mass adoption. Nevertheless, it served as a valuable testbed for Soviet firearms innovation. The 12.7mm grenade system operated semi-automatically with its own magazine beneath the launcher, while the 5.45mm barrel matched the AK-74's ballistics and reliability. Both barrels shared a single trigger, which could unintentionally discharge both if not carefully loaded. Only minor sight modifications accounted for the grenade's trajectory. Managing two different ammunition types and the grenade's small caliber limited its effectiveness, contributing to the weapon's rejection for service. The dual-piston gas operation and thickened receiver provided stability, with the 5.45mm barrel delivering AK-74-like performance, and the 12.7mm barrel designed for armoured or grouped targets. The 5.45mm barrel could also launch rifle grenades using a muzzle brake compensator. The open set to rear sight and centre line aligned front sight served both barrels. The 80.002 weighed 4.9 kilograms unloaded, measured 1000mm in length, and had a 1000-meter sighting range. Though never adopted, it remained an experimental platform into the early 1990s. The 80.002 was anticipated to be followed by later Western programs, such as the HK-XM29 OICW, with its roots in Yakushchev's earlier AO-38 rifle. Though the AO-38 was discontinued, its innovative side-by-side barrel design directly influenced the 80.002. The weapon's thickened receiver and dual-piston system foreshadowed later OICW developments. Its 5.45mm barrel performed like the AK-74, but with greater stability, while the 12.7mm cartridge targeted armoured personnel and groups. Adjusted sights and magazines for each barrel, along with AK-74 components, kept production costs low. Even after official development ended, it continued to influence future dual-barrel weapon concepts as a testbed into the 1990s. By the late 1980s, combined rifle and grenade launcher systems became more common globally, yet Yakushchev's 1973 design predated many Western equivalents. The 80.002 stands out as one of the earliest and most ambitious examples, though detailed records remain scarce. As a working prototype, the 80.002 revealed several limitations. Its shared bolt system likely produced high recoil and reduced accuracy in automatic fire. The lack of visible ejection ports suggests either a forward ejecting mechanism or incomplete prototyping, while the double bolt points to ambitions for independent barrel operation. The 12.7mm magazine's unusual width suggests non-standard rounds or blanks, but these proved impractical. Global trials confirm that sub-40mm grenades lack sufficient armor penetration and fragmentation, reinforcing the experimental and ultimately impractical nature of the 80.002's grenade launcher. Despite its forward-thinking design, the 80.002 was heavier and bulkier than the AK-74, limiting its practicality for widespread use. Its primary legacy was as an experimental platform for Soviet firearms technology throughout the 1970s and 1980s. The USSR's tradition of experimental double-barreled firearms began in the 1960s with the AO-38 rifle under Yakushchev. Although never adopted, these early efforts influenced ambitious later designs, such as the 80.002, which helped shape future multi-barrel weapon concepts. The dual-piston gas-operated mechanism and single return spring combined to create a robust receiver. The 5.45mm barrel matched AK-74 performance and could also launch rifle grenades, while the 12.7mm was meant to defeat protected targets. Similar ideas would later appear in Western OICW projects. Despite its innovations, 80.002 remained a prototype and a testament to Soviet experimental weaponry. During the Cold War, the US and the Soviet Union competed fiercely in weapons technology, leading to a wave of radical and experimental projects. One of the most ambitious was the AAI Close Assault Weapon System, CAWS, a weapon that blurred the line between engineering and science fiction. Born in the 1970s and 1980s, an era of rapid innovation, CAWS embodied the military's willingness to develop anything that might offer a battlefield advantage, no matter how unconventional. The era produced many experimental weapons. Some, like the SPIW Flechette rifle and the nuclear Davy Crockett, never gained widespread adoption due to their complexity or impracticality. Yet failures didn't stop designers from pushing boundaries. CAWS was intended for close quarters battle and was designed to exceed the capabilities of standard shotguns. The AAI CAWS was a select-fire, recoil-operated automatic shotgun with a 12-round magazine, capable of both semi-automatic and full-automatic fire. Drawing inspiration from the M16, it featured familiar controls and a modular design, which made it more accessible to soldiers. The system supported a wide variety of specialized rocket-assisted ammunition, including flechettes, SCM ITR rounds, armor-piercing, explosive, chemical and buckshot options, capable of penetrating wood or steel at significant distances. An adapter allowed the use of standard 12-gauge shells, further enhancing its versatility. Despite these advantages, CAWS was never adopted after testing. During field trials, soldiers noted that while recoil was manageable and the M16 style controls facilitated training, the weapon's significant weight and bulk made it tiring to operate for extended periods, and its unique magazine system was less intuitive than that of traditional shotguns. Maintenance in field conditions was also more complex due to the use of proprietary ammunition and mechanisms. The advanced Flechette and SCM ITR rounds provided impressive penetration in wound channels, sometimes up to 150 meters, but were expensive, less versatile, and sometimes inconsistent in accuracy due to their experimental nature. Visually, the CAWS had a boxy, industrial look, with a prominent magazine and used composite materials and modular construction, which contributed to its sci-fi reputation. The overall length was similar to an M16, but it was heavier and bulkier when loaded. Additionally, the cost and logistical burden of introducing a new weapon system and ammunition supply chain were difficult to justify, especially given improvements to existing shotguns and standard ammunition at the time. No foreign military adopted the CAWS, though the project drew international attention and inspired similar concepts such as the US AS-12 and Frankie SPAS-15, albeit without the CAWS's level of ammunition innovation. The CAWS program produced technical innovations including a proprietary belted ammo system, advanced recoil mitigation, a modular stock, and easy switch sights, some of which were patented and later influenced the design of tactical shotguns. However, no modern shotgun has replicated the CAWS's rocket-assisted, armor-piercing ammunition, leaving it unique even by today's standards. Exact program costs remain unclear, but the project spanned nearly a decade and produced only a handful of prototypes from several manufacturers. Most AAI CAWS units are now in museums or private collections. The CAWS's futuristic design has influenced depictions of shotguns in pop culture, including the Call of Duty and Battlefield franchises, where high-tech shotguns with drum magazines or flechette ammo are common. The combination of rocket-assisted large-caliber rounds with explosive or armor-piercing payloads also made the CAWS strikingly similar in concept to the iconic Warhammer 40,000 bolter, a fictional firearm famed for its self-propelled, explosive ammunition and devastating battlefield impact. Both weapons are designed to deliver maximum stopping power with high-velocity, rocket-propelled projectiles. The bolter fires bolts, miniature rockets with mass-reactive explosive warheads that detonate within targets for catastrophic damage. Likewise, the CAWS was intended to fire a range of advanced shells and flechettes capable of penetrating armor and inflicting lethal wounds, thereby bridging the gap between shotguns and light cannons. This parallel highlights the CAWS as a rare real-world attempt to realize the kind of firepower typically reserved for science fiction, turning the shotgun concept into something closer to a handheld artillery piece. Developed in response to lessons learned during the Vietnam era, CAWS targeted modularity, high capacity, and superior lethality. Its M16 style controls, 450 rounds per minute rate of fire, and 9-pound weight were intended to deliver adaptability for various combat scenarios. Its tri-cap and M16 inspired modular design ensured familiarity and manageable recoil. To clarify, flechettes are small dart-like projectiles designed for high velocity, deep penetration, while SCM-ITR rounds contain multiple flat, blade-shaped projectiles that spin in flight for stability and create wide wound channels. These innovations enabled CAWS to overcome barriers and achieve ranges far beyond those of typical shotguns. Despite its innovation, CAWS was abandoned in the late 1980s after prototypes failed to meet military standards. Reliability issues persisted during trials, and the complexity of the proprietary ammunition system created additional logistical challenges. As a result, the CAWS could not meet all of the US military's stringent requirements for adoption. CAWS embodied the look and firepower of a sci-fi rifle, firing rocket-propelled, large-caliber rounds with versatile payloads. The tri-cap, a compact, stockless personal defense weapon using the same ammunition, pushed the concept further with a 20-round automatic magazine. Though neither system gained widespread adoption, their ambition highlights the era's spirit of military innovation and willingness to pursue weapons that seemed straight out of science fiction. The Advanced Individual Combat Weapon, AICW, was an Australian prototype that integrated an F88 austere 5.56mm assault rifle with a Metal Storm-designed grenade launcher into a singular modular system. Serving as a technology demonstrator, the AICW was designed to enhance soldiers' firepower and battlefield flexibility. The AICW was developed collaboratively by the Defence Science and Technology Organisation, DSTO, Metal Storm, and Tenix Defence Systems, with funding from the Australian Government's Capability and Technology Demonstrator Programme. Prototypes include both 20mm and 40mm grenade launchers, and the VX-3 underwent live-fire trials in 2005. Designed as a proof of concept, the project ended after successful demonstrations. The AICW enabled operators to fire multiple grenades in succession and switch between a rifle and a grenade launcher without adjusting their sights or stance, thereby improving battlefield versatility. The AICW's grenade launcher used proprietary 40mm rounds arranged nose to tail to form a superposed load stack, breech-loaded with an induction coil for ignition. This design enabled the firing of complete projectiles without ejecting casings, streamlining the operation. While the design aimed to make the weapon more compact and lighter, some data indicate that the finalized AICW could have been heavier than the XM29 OICW. However, the tested prototypes were somewhat lighter, with DSTO scientific officer Stephen Forbes noting that a production model might weigh as little as 7.5 kg fully loaded, following a projected 380-gram reduction from the VX-3 prototype. The bullpup configuration of the AICW's 5.56mm system allowed for a longer rifle barrel compared to the OICW's KE module, which had been criticized for its short 250mm barrel and poor performance. Forbes also highlighted that the 40mm grenade rounds offered a greater explosive radius than the OICW's 20x20mm grenades, and the slight decrease in range was deemed a worthwhile trade-off for improved terminal effects. While the AICW weighed about 20% more than the M203 equipped F88 GLA, excluding sights and ammunition, it delivered a 25% increase in grenade velocity and included recoil mitigation for faster follow-up shots. By consolidating both 5.56mm and 40mm ammunition into a single, compact platform, soldiers could rapidly switch between munitions and fire several grenades without reloading, boosting operational speed and flexibility. The project concluded after successful testing and the end of government funding. Insights from the AICW's stacked munition grenade launcher design later contributed to the Metalstorm 3GL. Metalstorm reported the successful live-fire testing of the AICW Capability Technology Demonstrator at the Port Wakefield Proof and Experimental Range near Adelaide, Australia. The project, sponsored by the Capability Development Group of the Australian Department of Defence and led by the Defence Science and Technology Organisation, included Metalstorm and Tenex Defence as consortium members. The AICW combined a 5.56 Steyr assault rifle and a Metalstorm 40mm grenade launcher with shared controls, able to fire up to 3 grenades before reloading. During tests, the AICW's integrated launcher engaged targets at 1 to 300 meters and demonstrated reliable accuracy and improved lethality. According to Metalstorm CEO David Smith, the AICW's multi-shot grenade launcher marked a significant step forward compared to traditional combat weapons. He emphasized ongoing global efforts to develop fully integrated systems with advanced fire control, range, and optimized weight, noting that the AICW made notable progress towards these goals. The company aimed to further develop and commercialize the system, incorporating new Metalstorm technology and advanced high-explosive rounds. The project, a partnership between DSTO, Metalstorm, and Tenex Defence, ran from 2001 to 2006 and was initially budgeted at $3.2 million, taking inspiration from the American XM29 OICW concept. The AICW was conceived as a modular platform, combining a 5.56 rifle/carbine, a 40mm multi-shot grenade launcher, and advanced electro-optical sights. Its design enabled the efficient operation of both weapons and facilitated the transmission of reconnaissance data to external systems, reflecting the trend toward greater battlefield connectivity. The core rifle of the AICW was an extensively modified Australian-made F88, itself a licensed version of the Steyr AUG. The F88 was upgraded to accommodate the grenade launcher module on top and featured an enlarged buttstock to house the electronic fire control system for the launcher. Additional adjustments included revised safety and trigger mechanisms, with a single trigger operating both the 5.56mm rifle and the 40mm grenade launcher. A 3-position safety/selector switch, safe, rifle, grenade launcher, was conveniently located on the pistol grip. The AICW's Metalstorm 40mm launcher held 3 stacked projectiles, each fired electrically via the rifle's fire control system. It had a higher muzzle velocity than typical handheld launchers and included a recoil buffer to improve handling. The receiver of the AICW is equipped with a variety of multi-role sights from different manufacturers. During the VX3 live fire demonstrations in summer 2005, prototypes were fitted with either the ITL Viper multi-purpose rifle sight, which features a laser rangefinder and digital compass, or the Vinghog Vingsight fire control system. As of late 2005, the AICW prototypes had not yet conducted live firing of 40mm grenades with warheads or implemented an airburst capability. Nonetheless, existing 40mm grenade warheads can be readily adapted for use with the Metalstorm system, including airburst munitions currently being developed in several countries. Ultimately, the Advanced Individual Combat Weapon remained a 3rd-generation technology demonstrator, with its first full system live-fire trials conducted in 2005. Although the Australian Ministry of Defence considered acquiring AICW systems between 2010 and 2012, no production orders were placed. Nevertheless, the AICW project advanced understanding of integrated weapon systems and contributed valuable insights for future small arms development. France is renowned for its baguettes, wine, art, and onions. and its flair for experimental rifles that often resemble futuristic luggage more than military hardware. Among the most notable was the PAPOP Polyarmes Polyprojectiles, or Multi-Projectile Multiple Weapons System, a French attempt to develop a modular computerized infantry weapon for the Felin system. The PAPOP combined a 35mm grenade launcher with a 5.56 by 45mm NATO assault rifle in a bullpup configuration, enhanced by advanced targeting technology, and was designed to engage hidden or protected targets at ranges up to 600 meters. Despite its ambition, the project was ultimately abandoned due to multiple challenges. Let's meet the PAPOP, Polyarmes Polyprojectiles, the French military's bold vision for a future battlefield weapon. This modular system integrates a 5.56mm NATO assault rifle and a semi-automatic 35mm grenade launcher in a bullpup configuration. Designed for both direct engagement and the defeat of protected targets at ranges up to 600 meters. The rifle utilizes high-velocity sub-caliber ammunition, and the programmable smart grenades can be set for airburst detonation with selectable yields and fragment directions, resulting in a lethal radius of 5 meters and the ability to penetrate flak vests. An oversized selector allows quick mode changes. Advanced electronics, camera, night vision, laser rangefinder, IFF, and a targeting computer enable the PAPOP to program grenades and provide a swiveling LCD display for aiming from behind cover or around corners, offering a tactical edge in complex environments. Developed by a French-led consortium, GIAT, FN Herstal, SFIM, ODS, Euro Impact, Lacroix, the PAPOP was a core element of the Felin integrated soldier system, allowing networked sharing of targeting and reconnaissance data. Work began in 1995, aiming to replace the FAMAS by 2010 with a weapon effective against protected targets at ranges of up to 600 meters. The first prototype, PAPOP-1, featured a 30-round rifle magazine and a 3-grenade tube, but weighed 8 kilograms, making it impractical for infantry use. The improved PAPOP-2 reduced its weight to 6 kilograms, held 25 rifle rounds and 2 grenades, with a platoon version carrying up to 5 grenades, and emphasized practicality for urban combat. These iterations highlighted both the ambition and the technical challenges of creating an advanced modular weapon for tomorrow's soldier. Like the XM29 and K11, PAPOP combined a rifle and a grenade launcher, but the French design placed special emphasis on digital integration. Its targeting system linked a forward-facing camera, night vision, laser rangefinder, IFF, and a grenade programming computer to a swiveling LCD display powered by the stock. These electronics enabled aiming from cover and seamless operation within the Felin digital battle space, making PAPOP suitable for both direct engagement and networked reconnaissance. The dual-barreled layout was managed by a prominent selector switch for instant mode changes. Both the programmable grenades and the sub-caliber rifle rounds were designed to maximize lethality and penetration at up to 600 meters, providing a potential edge in various combat environments. PAPOP-2's redesign focused on reducing weight and bulk while retaining key features: a 25-round rifle magazine, 2 grenade load, up to 5 for platoon use, and a 5.56mm sub-caliber ammunition for 600-meter engagements. The semi-automatic 35mm grenade launcher kept its programmable airburst and selector switch, now in a more compact field-ready package. Advanced targeting electronics linked to the Felin network enabled safe fire from cover and real-time sharing of targeting data, fulfilling the vision of a digitally integrated infantry weapon. PAPOP-1's heavy and unwieldy build led to the development of the lighter PAPOP-2, with a platoon version able to carry more grenades and a prototype dedicated to the grenade launcher. These variations reflect ongoing efforts to balance firepower, weight, and flexibility for different operational needs. Ultimately, the project produced 2 main prototypes, the first rejected for excessive weight and the second improved for urban combat, but neither achieved mass adoption. The system's futuristic design captured interest interest, but highlighted the challenges of balancing innovation with practical reality. The PAPOP stands as a vivid illustration of both the promise and pitfalls of defense innovation. Its sophisticated blend of firepower, electronics, and digital integration set a new standard for ambition, but persistent challenges, including weight, complexity, and real-world practicality, blocked widespread adoption. The weapon's legacy endures as a case study in the need for balance between vision and operational reality in military development. The Special Purpose Individual Weapon SPIW was a decades-long United States Army project to develop an infantry rifle that integrated flechette firing technology with a grenade launcher. Originating from Project Salvo's 1950s findings, demonstrating the combat effectiveness of compact, rapid-fire weapons, SPIW aimed to boost hit probability using high rates of fire and multiple projectile ammunition. While the program influenced later efforts like the Future Rifle Programme and the Advanced Combat Rifle Programme, none of these initiatives succeeded in replacing the M16 as the Army's standard rifle. Prior to the Salvo tests, Erwin Barr of AAI Corporation was already working on singular and multiple flechette cartridges. The Navy supported his work with funding from the Office of Naval Research, leading to a 12-gauge shotgun shell capable of firing 32 flechettes. The Army later contributed funding, and AAI participated in Salvo testing. These flechettes could penetrate one side of a standard steel helmet at 500 yards, 460 meters, which was impressive given their low mass, but their accuracy suffered due to substantial dispersion, limiting their practical effectiveness. Further advances included adapting a Winchester Model 70 rifle to fire experimental XM110 5.6 by 53mm rounds, each launching a single flechette. This weapon had slightly less accuracy than the .308 Winchester 7.62 by 51mm NATO, but matched its penetration and featured an exceptionally flat trajectory, allowing it to be fired without adjusting sights out to 400 yards, 370 meters. Additionally, the rounds were extremely lightweight and generated almost no recoil, allowing for high rates of fire from a lightweight weapon platform. Project Salvo, initiated in 1951, aimed to enhance infantry effectiveness by firing multiple projectiles simultaneously, sparking experiments with lighter ammunition, flechettes, and rifle grenade launcher combinations. While the flechette's low mass enabled high rates of fire, these projectiles faced accuracy and safety issues. Salvo's research demonstrated that small, high-velocity projectiles could be as lethal as traditional rounds, but overall hit probability gains were limited. These findings led to the adoption of the AR-15, later M16, and in parallel, Project Niblick established the over-under flechette and grenade launcher requirement that defined the SPIW program. 4 companies, AAI, Springfield Armory, Winchester Arms, and Harrington and Richardson, submitted designs with H&R eliminated early for excessive weight. Winchester's SPIW had a soft recoil stock to minimize burst fire recoil, but the system was unreliable and abandoned. Its grenade launcher, however, was promising and developed further. Springfield's bullpup entry used tandem magazines, but was ultimately too heavy, as was AAI's otherwise straightforward and high rate of fire design. Despite technical improvements, such as updated grenade launchers and stocks, none of the prototypes met reliability or weight goals. By 1966, the SPIW program was sidelined in favor of the M16. The primary legacy was the M203 grenade launcher, derived from AAI's work and still in use today. In 1969, the Army launched the Future Rifle Programme, inviting AAI and other companies to submit designs using flechettes or micro-caliber bullets, continuing the Salvo concept. Budget cuts and technical failures, such as the AAI's design jamming, hampered progress. Flechette ammunition reappeared in the 1986 Advanced Combat Rifle ACR trials, but despite technical advances, none of the weapon outperformed the M16 by the required margin. The ACR program confirmed that multi-projectile fire could not sufficiently address shooter error. The Springfield Armory SPIW, one of 4 main prototypes, was best represented by its 1964 bullpup variant with a 60-round tandem magazine and a 40mm grenade launcher. Earlier and later models explored both bullpup and conventional layouts and various flechette rounds, but all included an integrated grenade launcher, a core SPIW requirement. Technical issues, especially excessive weight, persisted, preventing adoption. Similarly, AAI's entry, the lightest of the 4 and using the XM110 flechette round, reached high burst rates and integrated a grenade launcher, but was also stymied by reliability problems. The combined flechette and grenade launcher concept defined SPIW development throughout. The 1966 second generation AAI SPIW prototype introduced several key upgrades. It featured a new plastic stock and switched to the 5.6 by 57mm XM645 cartridge, an improved version of the XM110 round. To accommodate the longer cartridge, both the drum magazine and the action stroke were slightly lengthened. Although the barrels were technically smoothbore, a small section of rifling called a spinning cutter was added at the muzzle to spin the sabot and ensure it separated cleanly from the flechette as it exited. Seeking to further reduce weight, AAI also developed the DBCATA disposable grenade launcher system, available in both single-shot and 3-shot versions. The 3-shot model employed a harmonica-style loading mechanism. Between 1967 and 1968, AAI developed a range of third-person SPIW systems. These included a belt-fed light machine gun, a point-fire rifle with a central bipod, a short-barreled version, a bullpup submachine gun with a magazine behind the grip, and an updated version of the 1966 prototype with a single-shot DBCATA launcher plate. Responding to concerns about excessive muzzle flash and noise, a silencer was fitted to the barrel. The final SPIW variant allowed the foregrip to be swapped for a more affordable grenade launcher. This launcher was fed by single-tube or 3-tube magazines holding standard 40mm grenades, with the magazine inserted from the side and guided into place by a gear track and rail system. The original AAI SPIW fired the XM110, a 5.6 by 53mm flechette round, an early SPIW ammunition innovation. Later versions were upgraded to the 5.6 by 57mm XM645 cartridge, and experiments included variants like light machine guns and submachine guns. The SPIW Programme 1959 to 1974, based on the all-purpose handheld weapon APHHW concept from Salvo, sought to increase hit probability by firing several small, high-velocity projectiles in bursts, a shotgun effect. This led to flechette ammunition, small, arrow-like steel darts in plastic sabots, achieving high velocity and low recoil. The standard SPIW flechette was about 4 cm long, 1.8mm in diameter, and weighed 0.65 grams, with stamped fins for stability. Innovations included the XM110 round with a piston primer and the triple flechette Tround, a polymer-cased, triangular cartridge designed to fire 3 flechettes at once. This concept, based on patents by David Dardick, was promoted by Harrington and Richardson. In 1962, the US Army established formal requirements for SPIW rifles, which had to feature a 60-round flechette magazine, a multi-shot 40mm grenade launcher, and weigh under 10 pounds, 4.54 kilograms, when loaded with 60 flechettes and 3 grenades. The program sets an ambitious 4-year timeline for development and adoption as the Army's standard infantry rifle. 4 main contenders entered the competition: AAI Inc., Winchester, H&R Inc., and the government-run Springfield Armory. H&R was the first to be eliminated in 1964, as its complex 3-barrel, 24-pound, 10.8 kg design was deemed unsafe to fire. H&R's rifle used triple flechette Trounds, feeding from a 20-round container and capable of firing 500 rounds 1,500 flechettes per minute, with a 3-shot semi-automatic grenade launcher underneath. Springfield Armory originally aimed to design a modular rifle that could convert between conventional and bullpup layouts using a shared barrel and receiver group. By 1964, this idea was dropped in favor of a dedicated bullpup rifle, a gas-operated weapon with a 60-round tandem magazine and a 3-shot semi-automatic magazine-fed grenade launcher mounted below. It fired XM144 single flechette ammunition from a smoothbore barrel at about 1,700 rounds per minute in a full auto or 3-round bursts. Later, Springfield engineers developed a conventional rifle version with a 50-round, 4-stack plastic magazine positioned in front of the trigger guard. AAI's submission to the SPIW program was a piston-operated rifle that used XM110 ammunition in 60-round drum magazines. A unique feature was its 3-shot 40mm underbarrel grenade launcher, which fed from a 2-round tubular magazine behind the barrel. The XM110 rounds employed a piston primer deeply set in the cartridge base that used gas pressure from firing to unlock the breech as the firing pin retracted. While this design simplified the rifle's operation, it increased the complexity, cost, and weight of each cartridge compared to conventional ammunition. The AAI SPIW could fire at 600 to 700 rounds per minute in full auto and up to 2,400 rounds per minute in 3-round burst mode. Winchester's SPIW rifle, like Springfield's, fired XM144 ammunition from a 60-round drum magazine. It was a gas-operated weapon featuring a different recoil system, which allowed the receiver and barrel to move independently within a polymer stock to help absorb recoil. It maintained a consistent firing rate of 700 rounds per minute and included a 3-shot semi-automatic grenade launcher with a blow-forward barrel design. Testing of the 3 remaining rifles in 1964 yielded disappointing results. None met the necessary standards for accuracy or reliability, although the AAI and Springfield models outperformed Winchester's. A significant problem was the high cost of manufacturing sabot flechette ammunition. Both the XM144 and especially the piston-primed XM110 were expensive to produce. Flechettes could not be equipped with tracer material, and their limited size raised concerns about their battlefield effectiveness. The requirement for integrated multi-shot grenade launchers also created issues. These systems were heavy, making the weapons front-heavy and awkward to handle. Additionally, the single trigger mechanism for both the rifle and grenade launcher complicated operation and increased the risk of user error during stressful combat situations. After initial trials, only AAI and Springfield continued development, but neither met SPIW's ambitious standards. Both suffered from weight, reliability, and ammunition complexity issues, sabot fragments, and questionable stopping power among them. The program was discontinued in 1968. Later, the Army revisited flechette concepts in the Future Rifle System (FRS) and Advanced Combat Rifle (ACR) programs. But even with improvements, flechettes could not replace traditional bullets. Despite not yielding a service rifle, SPIW's influence persisted in subsequent research, most notably with the M203 grenade launcher, which remains in service. The Harrington and Richardson SPIW was a highly complex prototype assault rifle designed for the US Army's Special Purpose Individual Weapon program in the 1960s and the 1970s. The program aimed to combine a flechette firing rifle with a multi-shot grenade launcher to enhance infantry firepower. H&R's rifle competed alongside entries from AAI, Winchester, and Springfield Armory. The H&R SPIW stood out for its intricate mechanism and unique ammunition. It fired 5.6 by 57mm triple-bore rounds, triangular polymer-cased cartridges, each holding 3 5.6mm sabotted flechettes, similar to those in AAI's XM110. The Troun's design, with 3 bores per round, enabled the launch of 3 flechettes simultaneously for every shot. These lightweight rounds, linked by plastic tape, were loaded into a 20-round drum magazine, resulting in a total of 60 flechettes per magazine. The polymer cases helped reduce overall ammunition weight despite the weapon's bulk. The rifle's action, designed by David Dardick, inventor of the Tround, used an open revolving chamber. Each Tround was indexed from the drum magazine and lined up with 3 bores in a single barrel. When fired, gas pressure propelled the saboted flechettes forward, with the sabots discarded early and all 3 flechettes exiting the barrel together. A top-mounted gas piston rotated the cylinder by 120 degrees per shot, ejecting spent cases to the side. Beneath the barrel, H&R added a semi-automatic revolver-style grenade launcher with 3-round capacity, loading 40 by 46mm grenades from the rear. Despite innovative features, the H&R SPIW faced critical flaws that led to its early disqualification. The open revolving cylinder created serious safety hazards for the operator. Although the polymer Tround ammunition was light, the rifle's fully loaded weight reached 23.9 pounds, more than double the programme's 10-pound limit. The weapon was notably front-heavy and unbalanced, especially with the underbarrel grenade launcher. The Tround system itself was unreliable. Minor inconsistencies in the plastic tape links could cause the rounds to bulge or split, while the shared barrel space for the flechettes resulted in rapid gas loss. As each flechette left the barrel, pressure dropped sharply, leading to reduced velocity, accuracy, and range for the second and third flechettes. These problems created additional risks. Insufficient pressure could cause flechettes to lodge in the barrel, leading to catastrophic failure or operator injury. After rejection from the SPIW program, H&R attempted to update the rifle for the Future Rifle System program, rechambering it for 17 triplex Trounds with 3 sub-caliber bullets and removing the grenade launcher. This revised prototype was also rejected and the design was ultimately abandoned. The SPIW program stands as a testament to the ambition and challenges of military innovation. While it never produced a standard-issue rifle, SPIW's decades-long pursuit of increased firepower, advanced ammunition, and integrated grenade launchers pushed the boundaries of small arms technology. The persistent technical hurdles, especially surrounding flechette reliability, weapon weight, and operational complexity, highlighted the difficulties of translating experimental concepts into robust battlefield tools. Yet, the SPIW's legacy is clear. Its ideas shaped future American small arms development, most notably leading to the widely adopted M203 grenade launcher and inspiring further research into high-velocity, multi-projectile weaponry. In striving to reimagine the infantry rifle, SPIW advanced both the science and the art of small arms design, leaving a lasting influence despite never reaching full service.